Hello, physical science students in Mrs. Lewis's class. We are currently on Chapter 11, Electromagnetic Waves, and we're going to look into Section 2, the electromagnetic spectrum. The main idea for this chapter is the spectrum is divided into several sections, each with a certain range of frequencies and specific properties. So let's talk about radio waves. These are low-frequency electromagnetic waves and wavelengths longer than about 10 centimeters. Even though radio waves carry information that a radio uses to create sound, you can't hear radio waves. A radio wave does not produce compressions and rarefications as it travels through the air. Make sure you're coloring. Radar stands for radio detecting and ranging. With radar, radio waves are transmitted towards an object. By measuring the time required for the waves to bounce off the object and return to the receiving antenna, the location of the object can be found.
Ballistic missiles can travel thousands of miles in just a few minutes, leaving only a short window for the U.S. and its allies to respond. Different radar systems provide protection by detecting, classifying, and discriminating threats as early as possible. Radars work by sending out radio waves, which bounce off targets. The radar then analyzes the returning waves to detect, classify, and track potential threats. Different radars serve different purposes. Some use higher frequencies with shorter wavelengths for enhanced tracking. Others use lower frequencies and longer wavelengths for broader searches. Imagine scanning the night sky with a light. To cover a broad area, a beam that is wider at great distances would be best. But to hone in on a specific target, you'd want to use a powerful spotlight. Different radar bands give military personnel multiple detection options. The UHF band uses radio waves that can travel as far as the horizon to give up to a 360-degree view of potential threats. This is a critical capability for an early warning radar. S-band radars, like those of AMDR, use higher frequencies and are also ideal for broad surveillance, volume search, and ballistic missile defense discrimination. The C-band is ideal for mobile air and missile defense systems, such as Patriot, to detect and discriminate missile and aircraft threats. And the X-band, used by the AN-TB2 radar, is able to highly focus radio waves in a narrow window, offering a high-definition picture of potential threats. While no single radar does it all, the right combination of radars, working together, provide better search coverage, threat detection, and classification when every second counts.
If you are alive today, you've probably heard of an MRI. Either you or someone you know has had a sports injury or fallen, or maybe your grandma or grandpa's having some knee and joint pain and they had to go in for an MRI. Well, that stands for magnetic resonance imaging. This uses radio waves to help diagnose illness. The patient lies inside a large cylinder. Housed in the cylinder is a powerful magnet, a radio wave emitter, and a radio wave detector. Protons in hydrogen atoms in bones and soft tissue behave like magnets and align with the strong magnetic field. Energy from waves causes some of the protons to flip their alignment. As the protons flip, they release radiant energy. A radio receiver detects this released energy. And then the released energy detected by the radio receiver is used to create a map of the different tissues. Microwaves. Electromagnetic waves with wavelengths between 0.1 millimeters and 30 centimeters are called microwaves. You're probably most familiar with microwaves because of their use in microwave ovens. Microwave ovens heat food when microwaves interact and water molecules in food. Each water molecule is positively charged on one side and negatively charged on the other. The vibrating electric field inside of a microwave oven causes water molecules in food to rotate back and forth billions of times each second. This rotation causes a type of friction between water molecules that generates thermal energy. A third type, infrared waves. When you stand in front of a fireplace, you feel the warmth of the blazing fire. The warmth you feel is thermal energy transmitted to you by infrared waves, which are a type of electromagnetic wave with wavelengths between about 1,000th and about 750 billionths of a meter. Every object emits infrared waves. A remote control. Infrared waves can be used to evaluate how energy efficient a building is. And some ghost hunters use this as well. Visible light. This is the range of the electromagnetic waves that you can detect with your eyes. Visible light has wavelengths around 700 billionths to 400 billionths of a meter. Your eyes contain substances that react differently to various wavelengths of visible light, so you can see different colors. These colors range from short wavelength blue to long wavelength red. If all the colors are present, you see the light as white. Interesting. Make sure you're coloring this spectrum, and you will want to write next to the blue that this is the short wavelength and this is the long wavelength. Ultraviolet waves are electromagnetic waves with wavelengths from about 400 billionths to 10 billionths of a meter. Overexposure to ultraviolet rays can cause skin damage and cancer. When ultraviolet light enters a cell, it damages protein and DNA molecules. For some single-celled organisms, damage can mean death, which can be a benefit to health. UV rays can be used to disinfect water. So while we need UV rays, we need to be careful about how we're applying them. Some of the useful UV rays are fluorescents, okay? Fluorescent materials absorb ultraviolet waves and remit the energy and visible light. Police detectives sometimes use fluorescent powder to show fingerprints when solving crimes. The ozone layer. About 200 to 50 kilometers above Earth's surface is the stratosphere. Ozone is a molecule composed of 3 oxygen atoms. It is continually being formed and destroyed by ultraviolet waves high in the atmosphere. Most of the ultraviolet radiation that reaches Earth's surface are no longer wavelength UVA rays. The shorter wavelength UVB rays cause sunburn, and both UVA and UVB rays can cause skin cancers and skin damage, such as wrinkling. So one of the things that I tell people is UVA, A is for aging, and UVB, B is for burning. So if you're speeding up the aging process, you're clearly going to be speeding up any cancer cells that may be lying dormant. UVB rays are burning, so whenever you do damage to a cell, you can ultimately get skin cancer from that. So make sure you wear your SPF. The decrease in ozone might be caused by the presence of certain chemicals such as CFCs high in the Earth's atmosphere. These are chemicals called chlorofluorocarbons that have been widely used in air conditioners, refrigerators, and cleaning fluids. Basically, everything that makes our life easier as humans affects the ozone layer in a negative way. So these react with the ozone high in the atmosphere, and this reaction causes ozone molecules to break apart.
Ozone, the thing that protects us from the sun's UV radiation. Without the ozone layer, us humans would burn massively, like really bad burns. Wow, that was graphic. But this is quite possibly what could happen to us if we carry on this way. And when I say this way, I mean destroying the ozone layer by releasing damagingly deadly chemicals that break down this layer dramatically. So this ozone actually protects us by 97% of all UV radiation. So instead of looking like this on a day on the beach, you might possibly look like this. In Antarctica, there is a problem. Since 1980, a hole has been growing in the ozone, and if you rewind a bit, you may remember something. So this ozone actually protects us by 97% of all UV radiation. So, If you think about that, on a normal hot, cloudless day, the burns you get are only 3% of the UV radiation. So if we times those burns by 32.3 times, that is what you would get without the ozone being there to protect you, which is rather scary. In 1987, governments signed up to an international agreement to stop using CFCs by 2000, except for the essential safety uses. And even though it is 14 years later, they have seen...
Make sure you're writing down the different information from the video about how much the ozone layer usually protects us, how much we are typically exposed to, and if he's giving you data on, hey, in 1987, this is what happened, and this is why we did it, and this is what it's called, I would make a note of that on my notes, and I'm highly suggesting that to you.
But it is taking a tad longer than originally thought. However, all these gases, even though reduced, are still hovering around the atmosphere and will remain there constantly, destroying our ozone. It may even take hundreds of years for them to be degradable again. So if it does take hundreds of years, the ozone hole in Antarctica may be almost triple its current size. How is ozone formed and destroyed? Well, when an oxygen atom absorbs UV radiation, it splits, forming two lone oxygens. But these particles need a partner, so there is 3 ways of doing so. Number 1, it can join another lone oxygen to make a pure one. Number 2, it can join a pure oxygen to create an ozone atom. Or finally, number 3, it can join an ozone atom to create 2O2, which is 2 pure oxygens joined together.
X-rays and gamma rays. X-rays have wavelengths between about 10 billionths of a meter and 10 trillionths of a meter. The electromagnetic waves with the shortest wavelengths and highest frequencies are X-rays and gamma rays. Both X-rays and gamma rays are high-energy electromagnetic waves. Electromagnetic waves with wavelengths shorter than about 10 trillionths of a meter are gamma rays. These are the highest energy electromagnetic waves and can penetrate through several centimeters of lead. Not even Superman could see through lead. Gamma rays are produced by processes that occur in atomic nuclei. Both X-rays and gamma rays are used in a technique called radiation therapy to kill diseased cells in the human body. That concludes our note lesson for this section. Make sure you made notes from that movie. If not, it's not going to be helpful to you when we have a quiz. And make sure all your color pages have been colored and labeled. Thanks.